here to talk about Promises A+ and the story behind that. So I'm Domenic, and thanks for having me. Happy to be here. I want to start out by talking about what I think the JavaScript community's greatest strength is. And I think it's that what we do a lot is we turn tiny primitives into powerful patterns. And I think one of the most amazing examples of this in recent times is the ES5 module systems that we've seen crop up. Things like CommonJS modules or AMD modules, where we've taken these hacks, really, built on top of factory functions and objects, and turned them into a language feature that was missing from our language and allowed us to create package managers and an amazing ecosystem on top of that. But we see this over and over. This is a general pattern that we do, something like just modules, but also we have classes built on this prototype hack, and we have callbacks that are built, we pass functions to other functions, and we have streams, and we have events. Event emitter is not part of the language. There's no actor pattern built in, but we're able to do this. I mean, something as small as jQuery's chainable API is an example of this. That's not a language feature. That's something we've built. And essentially, we just use these function and object primitives to cobble together amazing applications and to propagate the wisdom of our patterns throughout the community. And I mean, it's a bunch of hacks, but it's a bunch of practical hacks, and that really fits with the spirit of JavaScript itself. As its genesis in 1995, and Brendan Eich's like, hey, let's put this Lisp's semantics in some Java syntax, and cool, let's go. I mean, that's how JavaScript works. But I think this is also our greatest weakness. I think we become prideful in our ability to shape worlds out of the primordial stardust of function. We get stuck in patterns. We say that because a certain thing is easiest to express in terms of function, it's therefore the best pattern to use in JavaScript. And more generally, I think that we assume that the best ideas are those that can be expressed most easily in terms of JavaScript and most naturally in JavaScript. And we often refuse to learn from other languages and the lessons that have come from other spaces. So the Promises A+ story that I want to tell you today is a story where we actually, as a community, overcame this weakness. And I want to kind of talk about how that went and why it's important for the future of really the web and the language in general. So of course, we first have to have a minimal introduction or talk about async programming. But I want to take a step back and be more general about this than the usual just async and JavaScript, yay, callbacks, whatever. Right? The async programming revolution is something that's been going on for a long time in a lot of programming languages. JavaScript may have made it popular, but it's not the first place these ideas have been. It's popular because JavaScript is popular, but that's not the foundation of these ideas. And actually, JavaScript is actually one of the worst languages for async programming. And I think the reason for this is largely historical. JavaScript's initial asynchronous APIs came from this wonderful set of APIs called the DOM. And we all know how pleasant DOM APIs are to work with, but that's where they came from. So essentially, all JavaScript asynchronous APIs end up being in this thing called continuation passing style. And here's a Node.js example, because Node.js kind of tried to clean up the DOM's legacy, but they just latched onto that train where you want to do something asynchronous, you pass a function to another function, and you stuff all of the rest of your code in there. We call this continuation passing style. You pass a continuation of your program to somewhere else. I mean, Node decided on a common signature for its callbacks, kind of getting away from the DOM's mess of, sometimes we'll use events, sometimes we'll use callbacks, sometimes we'll just do whatever. But then most of the time it's consistent, but it never took a step back and said, what's the landscape of design patterns for asynchronous programming? How could we kind of look at what other languages are doing or what other frameworks are doing or what's possible when you want to do asynchronous programming? It just stuck with what the DOM was doing, which is just continuation passing style. And I think this is generally part of the trap that we often fall into, the more functions trap, I like to call it, and you spell it M-O-A-R. And where you do literally the simplest thing possible. So continuation passing style, in my opinion, is easy, right? Everyone can do it. Callbacks are easy, but it is not simple. So easy in this sense, I mean, it's like the nearest thing you reach for. It's a very familiar tool. You reach out, and functions are there, and you pass functions to other functions. and you need to do an async operation, you just stuff the rest of your code in a function. Everyone can do this. Like, if you can't do this, you're kind of a JavaScript noob. And like, people will make fun of you, but they kind of should, because this is a very JavaScript thing to do. Like, I'm not kidding. But the thing about continuation passing style is it is not simple, OK? It is not, what do I mean by that exactly? Like, what's the difference here that I'm trying to get at? Well, I think the way that I've kind of come to think about this over the years is that continuation passing style traps you in something called the Turing tar pit. And this is one of my favorite conceptual entities. It's the idea that, you know, because you have a Turing complete language, you can just cobble together whatever program you want. You rebuild whatever you need. And this is often seen in the DOM or in, you know, in the browser where you're like, oh, I have JavaScript. I'm just going to redo all of the browser's primitives in terms of JavaScript. Like, you're getting trapped in the Turing tar pit. But it's the same thing. You're in asynchronous programming in JavaScript land, and you're like, oh, well, I have JavaScript. I have a Turing complete language. Let me just cobble together an asynchronous abstraction, like using the basic JavaScript stuff. And the problem is that, as with all Turing tar pit things, you end up reinventing basic features of the language. Something like returning a value, or throwing an error, or a call stack. You lose those, and you try and reinvent them by cobbling together these crazy combinator functions that just tie together other functions to try and express your basic ideas. And of course, it's not hard, right? Everyone can do this. This is easy stuff. But it's not simple at all. And this kind of complexity that comes out really has the kind of maintenance and cognitive burdens that you would expect from a complex system. You know, you're always asking questions, or, you know, second guessing yourself. You're saying, did somebody accidentally call my callback twice? Or, you know, did they call it with both an error and a value? Or what's the value of that thing I use to do things in parallel? It's like a counter sometimes, but sometimes it's a map. But I don't know, like, did I remember to pass up the errors to my caller? Like, the answer to all these questions should always be, I don't know and I don't want to know. I don't care. I just want to do an asynchronous function call, and I don't care how. Like, that would be something that was simple. But continuation passing style and callbacks in general are not simple. So the way that other languages have solved this asynchronous function call paradigm, if we want to look to them for lessons, is by a concept called promises. And it comes from some very old languages. Joule and E are kind of the originators of these. And these are somewhat academic languages that haven't seen that much practical application, but they're really interesting. And they have some first-class support for this kind of asynchronous function call idea. But it's made its way into a lot more mainstream languages, as you can see. You know, it's in Java, it's in Python, it's in F#, and via F# it got into .NET in general. It's in C++. Now, of course it's in Dart, because Dart have everything. It's in JavaScript in the form of promises A+. And so I think it's interesting seeing this list, because generally when you see a list like this, where all these languages have adopted this feature, it generally means either one of two things. It means that the idea is so good that everyone had to copy it, or it means that there's some convergent evolution on a solution that everyone agreed was a really good one. And promises, I think, are a bit of both. So, you know, to convince you of this, I don't really want to show you how to use promises in JavaScript. I think there's a lot of good blog posts on that. It's fun. I'd love to, you know, do a little tutorial. But I think I want to kind of blow you out of the water here and say why you should use promises in JavaScript with some really compelling examples. So the essential point of promises that I want to show with these examples is to give you back, is that you're going to get back asynchronous versions of return and throw. So instead of thrashing wildly in this Turing tar pit only to sink further into this callback molasses, we're going to turn our attention to an abstraction that can bring us back into the semantics of JavaScript, the language, the one that we're used to. We're going to create an asynchronous call stack with these promises, regaining all the semantics of the language, just like with synchronous return and throw, and we're going to integrate well with synchronous return and throw. And so I think for this reason, promises are fundamentally a simple thing. They allow us to compose our stuff in the same way that a normal language construct would. And you can compose asynchronous function calls with promises without having to entangle your concern of calling the asynchronous function with the function's concern of calling your callback. And so I think the first really drastic demonstration of this is available to you, actually, if you go to Chrome Canary and turn on some experimental JavaScript flags. So let me show you about something called generators. So this is actually not promises related at the moment, but So the idea here is you declare this special type of function called a generator function, which gets a little star next to its name, not a typo. In the middle of these, you can put statements like yield. So in this example, this function yields up a few numbers, and in between the yielding, it logs some console statements, A, B, C, D. And so when you call the function, it doesn't actually execute any code right away, but instead it gives you this iterator object. And then when you call next on that iterator object, it'll execute the code. It'll log A and yield you this 1. And what that translates to is this object, value 1, done false, because there's still more code to run. But the rest of the code doesn't run yet. So this is starting to look really interesting. This is something we don't have in JavaScript, the ability to pause execution of a function. And it's still completely single-threaded, and there's no like blocking thread stuff going on here, but we've paused execution and said, well, let's just not execute the rest of the code. And so you keep calling next, you keep executing more pieces of the code, all the way down until you get to the end, when after you've yielded 3 and got value 3 done false, you call next again, and you get D, value undefined, done true. So this is pretty magic, and I think what's really fun is that if you go to this JS bin link and turn on your Chrome Canary flags, you can actually see this in action. You can write this code and it works. And so that's pretty amazing, and I'm really excited about the next version of JavaScript in general, but I think this is really powerful. Because this idea where we pause function execution, go off and do something else, and then come back is exactly what we need to implement something like asynchronous code that integrates well with our language. And with promises, because they're an abstraction for asynchronous functions that integrate well with our language, we can do exactly that. So using the Q library, and this is also code that works today in this JS bin, you can do something where you do an asynchronous function call to this getRepoEvents function I wrote, which is also written with promises and generators. And you use the yield keyword to suspend execution until it's ready to come back. And then it goes and updates the UI and so on. And I'm also using yield down there to delay for 5,000 milliseconds. And what's amazing here, and what you don't see in a lot of these solutions, is we integrate well with the surrounding language constructs. And in this case, I'm using try, catch, finally. This is not something you can see. And you no longer have to do these crazy like combinators to say, oh, well, sometimes there's an error. Let me handle that. Well, but in both cases, I want to execute the finally function. But if that throws an error, then I do want to propagate that, and so on. You get all that for free, because promises as a solution integrate well with the language. And they can be directly dropped into a generator solution for when the language evolves that. And so, yeah, it's pretty awesome. All right, so the other major thing about promises that I think is really cool and kind of gives you an idea of their power is that as a bonus to just this fitting well with the language abstraction, we get time travel, as I like to call it. Because promises are objects that represent another object that will eventually be available. It's an object from another time. And so you can get a really fun example of this with this unit testing assertion I've put down at the bottom. And I have a library that does exactly this. It's called chai as promised, where you can say, I eventually expect this object to deep equal these things. So if you've ever done asynchronous unit testing, it's easy, but it's not simple, as I emphasize. It's a pain. It's not as simple as it should be. But let's actually step back a second and let Justin Timberlake tell us what's cool. Because time travel isn't cool, really. I mean, I don't know well, I kind of disagree with him, but he thinks that space travel's much cooler. So let's look at this example. So this goes a bit beyond basic promise stuff, which is usually just then. But the idea is you have something like a promise for a user, and you call this get method and to get a property called repos, and that actually gives you a promise for the property called repos. And you keep chaining off of that. You say, oh, we're going to get the promise for the property 0 of the repos, get a promise for the property commit history of the 0th repo. And then I'm going to invoke this function, so I'm going to promise for the results of the invocation of the toHTML function on that commit history. And then I'm going to display it in the UI, and then I'm going to get it done. And I do want to point out that in ECMAScript 6, with the proxies feature, this is going to look really pretty, just like all our backbone code where we do get, set, blah, 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 and all our Ember code and so on is going to look a lot prettier. But it's not just OK, here's some nice syntactic sugar for some common promise operations like getting properties and invoking methods. What if I told you that the user promise was actually a promise for a remote object, an object on another computer? Right? So everything here takes on a new meaning. right? What's happening is not just that we're saying, oh, queue up these actions to be taken in the future. We're saying, queue up these actions to happen on another computer. And then the computer will say, oh, well, he called then. Let me send back what I've currently computed, the HTML rendered on the server. So if you're Twitter and you don't believe in rendering things on this client, this might be a good way to go. So I think this is really neat because we've got an abstraction that was originally meant for kind of asynchronous programming, but essentially it can be used for distributed programming. So we really know we're onto something kind of fundamental here. All right. And you can actually do this today using a library by Chris Kowal, who's sitting right there, called QConnection. And in this case, the remote sources can be a WebSocket, a web worker, or a message port, which is a way of communicating among iframes, usually. And so you can get a promise using using libraries today for a remote user object. And then you can queue messages to send across these boundaries to remote computers or remote iframes or whatever. And so this is, I think, a really neat demonstration of promises that goes beyond the normal stuff. So that's kind of the end of the promises are really cool part of the talk. And now I want to talk about something that I think is really impactful for kind of how JavaScript as a community and a language evolves. The story I promised you earlier, where we overcame our greatest weakness of the desire to build everything and reach for the easiest thing, and so on. And so the story of Promises A+, it all started with this thing called CommonJS Promises A. And actually, if you look at this message, it's by a guy on the CommonJS mailing list proposing to base it off of Dojo. So it actually all started with Dojo, which, as we learned 2 days ago, it started everything. But the idea of Promises A and Dojo promises before them just captured the core idea of promises from all those other languages we saw, the idea of an asynchronous computation in an object. But it had some problems as a community-created spec. It was underspecified. It was missing some key features that all implementations actually ended up implementing. It was written in some paragraphs of prose that were really easy to misinterpret. And one of the unfortunate consequences of this easy to misinterpret nature of the spec was, as I like to call it, moneybags.deferred. So moneybags.deferred, this is a screenshot of a issue tracker while I'm arguing with its maintainer, kind of saying, hey, it would be really cool if you guys adopted the Promises A standard instead of this misinterpretation of it you have. And the response is like, sorry, it was 3 a.m. when I was reading that spec, and I got it wrong, and now we're stuck with it. So too late. And so they had a really bad reading comprehension issue there. Like, they missed the whole async-sync parallel. And so these deferreds, as like whatever, like they don't match promises conceptually at all. They don't integrate well with the language. They don't do the async return throw thing at all. So they failed reading comprehension, and I think the only realistic response to that is a Godzilla facepalm. So whatever, I'll do my own thing. I've recently been added to this Q library by Chris Kowal. But I swore a solemn vow on the grave of the dead callbacks that I'd buried that I'm not going to let this happen again. So when, sometime later, this library you may have heard of called Ember got a pull request that said add ember.deferred mixin, which implements the Promises A spec, I took a look at the code, and I found out that actually those are horrible, horrible lies. And we'd seen like this misinterpretation of Promises A had gone on again, and it's really a systematic problem. And so, the first appropriate response to that is, of course, a double bunny facepalm. But after I was done with that, I got really angry, and I wrote this rant called "You're Missing the Point of Promises." And this kind of had surprisingly large circulation, which was cool. So people were listening to what I wrote, and people really seemed to understand it, like the idea that, oh, wow, these libraries are missing the point of promises. They're just using it for like callback aggregation. They're not trying to integrate well with the language and provide a sane asynchronous primitive for a value that represents an asynchronous computation. And at the bottom of the gist, I wanted to end on a positive, productive note, not just like I'm ranting on the internet. I said I would produce a test suite. And once you put something on the internet with a promise, you really have to do it. Otherwise, people will hate you forever. So I did. I produced a Promises A test suite which people started using, which I thought was really cool. And at this point, actually, Yehuda Katz, one of the main people behind Ember.js, got in touch with me, and he said, yes, we totally want promises A compliant promises in Ember. We don't want to make that jQuery mistake. And he created this library called rsvp.js, which is one of the more popular promise libraries today. And I think this was really kind of the start of something great. So here's a screenshot of that test suite that I created. And I mean, I'm very happy with how many people started conforming to that. But then the real magic happened. So what happened next is this guy called Brian Cavalier, who should be in the audience, but I haven't seen him. There he is. Yeah, he created this gist, or gist, a gift, something, called Promises A+, which is a brilliant name. I wish I thought of it, where we're going to take Promises A, and we're going to clarify it. We're going to say, let's put this in like real language, not a few paragraphs. Let's put this in like spec-ish type bullet points and kind of say what exactly are the requirements that have emerged over the last few years of promise implementation in JavaScript. What do we need to create an interoperable set of promise implementations? And from that little gist, we ended up with this beautiful GitHub Pages website. You can tell that I'm a designer. No, really, it's a pretty nice, spec that we created, and it's got its own domain name now, promisesaplus.com. And this time we actually made a test suite, unlike the poor Promises A guys. If only they'd known how important that was. And then jQuery, well, OK, but so what? So we created this spec, and we put it up on the internet, and it has its own domain name. Woo. But it turns out that when you write a clear and thoughtful specification for something that people like to do, like people have been doing for a while, like promises, and you create a nice test suite for it that's very thorough, then people get really excited about implementing that. So we've ended up with over 30 implementations of Promises A+ spec. And we've actually ended up ones with ActionScript, Python, and Objective-C, which I think is pretty amazing. And what's great about this is not that, yes, we've forced everyone to conform, because we really made sure to only specify the core piece of the promise implementation that's important, the then method. And every implementation now has a good then method, which means you can build libraries that work with any implementation. You don't have to choose one and say, oh, everybody has to use my Promises A+ implementation if they want to benefit from my library. So this is pretty awesome. And actually, there's another implementation of these that ended up in the DOM spec under the wonderful name DOM futures. Not sure what that's about, but DOM futures are kind of like DOM promises. But seriously, we have promises in the DOM now. And there's been major work throughout the WhatWG and the W3C to encourage the use of these DOM promises, these DOM futures, in upcoming APIs. I mean, it's actually gotten kind of ridiculous the amount of times the mailing list posts get responded to with, oh, you should use futures. Like, there's some, if you don't have an API that's using futures, you might as well just set some up just in case. This is from an amazing site called w3cmemes.com. So that's that. But even more cool than that, I think, even more cool than getting our Promises A+ spec into the DOM, is for ES7. This is a presentation that was recently given at a TC39 meeting. There's a slide saying, we're going to try and get these kind of cool concurrency things in there. And as part of that, we're going to try and create a promise implementation, standardize it in ECMAScript 7, in the language, based on Promises A+. So what just happened? Somehow, Promises A+, this little thing we put up on GitHub, became the starting point for any conversation about promises in JavaScript. How did we end up supplanting Promises A so dramatically? And why am I getting weekly queries about whether jQuery will fix their broken promises? Wow, jQuery, they have so many users, but people want them to conform to my spec? How did we go from some nerd rage over a pull request to Ember to something that's influencing the DOM and even ECMAScript 7? How did a bunch of implementers congregating on GitHub and doing our own thing suddenly end up influencing the WhatWG and the W3C and TC39? This is amazing. So to end my talk, I want to kind of point to some principles of this thing calling open specification development. So it's the answer to the question, what made this Promises A+ effort work so well and be so influential? I think it boils down to a few principles of this idea. So going through them in turn, our cause of bringing sane asynchronous programming to JavaScript is this is the stuff we talked about earlier. This is important. This is kind of something people can get behind. You can't build a specification like this around things nobody cares about. You need to solve real problems, and you need to solve them with coherent solutions. You need to have something that people really can get behind and have been using and need to solve in the real world. The next thing, the people, right? We have a really strong and cooperative community working on Promises A+. It's led by Brian, who really did a great job, herding all of us sheep into the GitHub repo to talk to each other on a good ground. And we all care deeply about these issues, and we all were willing to make sacrifices and change our own implementations to conform to something that would be a core set of behaviors we could all agree on. The code. So this is probably the biggest reason. And this is all about what I was saying at the beginning, how we harnessed the JavaScript developers' desire to create everything from function and object. We'd already done this. We had implementations like when and Q, and RSVP was starting to get some buzz, where we'd implemented promises in JavaScript itself. And we did this before we banded together. So the idea that we have these existing implementations that had already explored the problem space and decided, oh, well, this is kind of where we're converging. It all ends up looking kind of like this. Let's just get all the edge cases narrowed down and create something we can agree on. And in short, this is code before prose, right? Get your code made, get a polyfill, as they call it, this is what the web API of the future probably should look like out there before you write down a spec and say everybody should follow this. The contract, right? So the contract of Promises A+ is a very small thing. We only specify the core then method, because that's enough. That's enough to get interoperable promises that everyone can use. We could have been fighting over whose API to standardize. No, I want the Q API. No, I want the when API. We didn't even specify how do you create a promise. We just specified once you have one, how does it have to behave? And this is why I like to say that the DOM future is a Promises A+ promise implementation, even though it is itself a spec. Because just like Q or when, it's building on this core interoperable then method that can work with other then methods and other libraries to create a larger surface area that its consumers can use. And its consumers are, in this case, browsers. Finally, and this can't be underestimated, the setting of GitHub plays a large part in our success, right? GitHub is where we, as a community, work and play. It encourages easy forking, pull requests, reviews. It has Markdown, which, Markdown diffs are really easy to read. So if you come into a repo and you want to see what's been going on with the specification, you can actually tell what's going on. If you look at some of the history for the W3C APIs, it's this massive HTML, and you have no idea what's going on. But everybody, that's part of, everybody knows how to interface with GitHub in this community. We all know how to look through old issues, how to send a pull request, how to look at diffs. This is where we congregate, and this is how we should be working. And even the W3C and the WhatWug are starting to get in on this. They're starting to see this. They put some of their specs on GitHub. But they haven't really made the transition because they still cling to these archaic old mailing lists with these archives that are impossible to navigate, and you can't really jump into the middle of a conversation very easily, and it's very frustrating trying to get involved in the standards process when you have to subscribe to these things that bombard your inbox in this 1990s way. So I think GitHub is a big part of why we were able to collaborate so well. So to close, I want to take a look at our slogan, our tagline for Promises A+. We spent a lot of time getting this right, actually. I mean, it's a bit silly sometimes, but in the end, I think it's perfect. We end up meaning every word. The Promises A+ organization and the standard, we're open. We do everything on GitHub. It's out in the open. We're sound. That's our cause. We want sane asynchronousy in JavaScript. We're interoperable. That's the core contract we're providing for everyone. And we're by implementers and for implementers, reflecting our commitment to build on existing code and to leverage the strength of the community we already had. So if you have all these open specification development ingredients in place, then I think you're in a place to extend the web forward. And this is referring to a concept that started becoming popular recently. It's a specific philosophy championed by the newly reformed W3C Technical Architecture Group, and in particular by Yehuda Katz, Alex Russell, and Brian Cardell. And the essential idea is that when we build things on the web platform, it shouldn't be magic browser APIs that go into C++ and do crazy things and we don't have any idea how to interface with. It should be core primitives in JavaScript that then build on each other and allow us to create the next version. And so then we have this virtuous cycle, just like in Promises A+, where the community says, oh, I have these tools. I'm going to build a new API on top of them. And then the community can compete between themselves and refine and converge around something. And eventually, a common primitive gets established, and we can take that back into the web platform itself. All right. Thanks.